Welcome to my channel Electronic Science Tutorial. Today is the 5th class of Operational Amplifier or Op-Amp. Today I will discuss the applications of Operational Amplifier or Op-Amp circuit. The first I will discuss the inverting amplifier circuit by using Op-Amp or the inverting amplification by using Op-Amp. So without any time waste, let's start our class. So what is the inverting amplifier circuit? This is the inverting amplifier circuit by using op-amp. Here one input resistor is connected at the inverting terminal and one input voltage is connected at the inverting terminal. The non-inverting terminal is connected with the ground connection, and this is the inverting input terminal and this is the output terminal. This input and this output is connected through a resistor, that is RF or the feedback resistor. So this is the circuit of an inverting amplifier by using op-amp, where we use one input resistor, that is R1, one feedback resistor, that is RF, and one input voltage, that is V1. So how this circuit is performed as an inverting amplifier? Let's talk about this topic. First of all, we know from the ideal op-amp characteristics, that is the voltage gain of an op-amp has infinite. How we calculate voltage gain? Gain is the gain equal to, or gain is the ratio of output voltage by input voltage, right? So if we consider the gain is infinite for ideal op-amp from ideal op-amp characteristics, that means we know gain equal to output voltage by input voltage, right? And if from the characteristics we also know that the gain is high and it is tends to infinite, that means gain is the infinite, then what is the input voltage value? That is 0. This is this point. This point is called the virtual ground point, where we consider this infinite voltage gain. That means the inverting input terminal is practically at the ground potential. Thus, the point G is not actually connected to the ground, but it's virtually connected to the ground potential. There is an important difference between an actual ground and an virtual ground. When a terminal is actually grounded, when any amount of current flow to ground through the terminal. Thus an actual ground can serve as a sink for infinite current. But the input impedance of an op-amp being infinite, no current flow into the op-amp through the virtual ground. So a virtual ground cannot serve as a sink for current. So there is a difference, basic difference between a actual ground and virtual ground. We know the voltage gain means output voltage by input voltage. The ratio of output voltage by input voltage is called the voltage gain. And from the characteristics of the op-amp, we know that the gain is infinite for op-amp. If the gain is infinite, then the input voltage is 0. Thus input voltage cannot be directly connected to the ground, but it's virtually connected to the ground. That's why we can say that this point, this G point, is said to be grounded. Okay, we can consider it. Thus, how we calculate the input resistance in this arm, in this inverting arm, that is, the current through the resistance R1 is, there is a voltage we applied, that is V1, and there is a voltage we also consider, that is a virtual ground, right, G point. That means this voltage difference divided by R1, the current through the resistance through this arm, that means I equal to V1 minus V divided by R1. Now what is the feedback current from this point to this point? From here we consider one ground potential, and here we get the output voltage V0. So the voltage difference is V minus V0 divided by RF. That means the current through the feedback resistor RF is V minus V0 by RF. Now we apply the Kirchhoff's current law at this point. Kirchhoff's current law what say? That is, the entering current is represented by positive sign and the leaving current is represented by minus sign with respect to this point. That means if we applied KCL law at this point, what we get? We get V1 minus V divided by R1 minus V minus V0 divided by RF, that is equal to V1 minus V divided by R1 equal to V minus V0 by RF. As we already considered that the G point is virtually ground, not actually ground, but it's also virtually ground. That means V is the 0 point. V is 0. We can consider V equal to 0. Then how the equation reduce? That is V1 by R1 equal to minus V0 by RF. That means V0 equal to minus V1 into RF by R1. So now the question is, how this, from this expression we can say that is its work as an inverting amplifier. Inverting means if we get positive signal we get negative output, if we put negative signal we get positive output, right? So here we saw that if V1 is 5 voltage, then it is inverted by this negative sign. We get already minus 5 volt. If we applied plus 5 volt, we get minus 5 volt, right, at the output. If we get minus 5 volt at the input, if we put minus 5 volt at the input, we get plus 5 volt at the output. That means inverting working is already done by this expression, and RF by R1 is used to amplification this process or this signal. That means if we consider that is RF value is 10 kilo ohm and R1 value is 1 kilo ohm, then 5 volt into 10 kilo ohm divided by 1 kilo ohm, that means 5 is multiplied by this 10, that means we get here minus 50 volt. We apply positive 5 volt input voltage, we get negative 50 voltage output. What is the voltage gain? Output voltage by input voltage. So output voltage is 50 volt, input voltage is 5 volt. That means 10 times gain here occur. So that is the amplification part. So first of all the signal is inverted, then it is to be amplified. So by this expression we can say that op-amp can be work as an inverting amplifier. V0 equal to minus V1 into Rf by R1. If we vary the feedback resistor value, we get different gain of input voltage. Okay. So this is the simple circuit of an inverting amplifier by using op-amp. Hope you understand this topic. Thank you. If you like, do like, share and subscribe my channel.